Hey class, so here's another problem that I'm going to try to help you guys out with. Some people have been asking already about problem 18 on the homework, which is the one with the two cars. This one's a little bit tricky because, as you can see in the problem statement, we're not told anything about the mass of the car that's rolling down, and so, yeah, that might become difficult. So let's try to get started. What we're asked to determine here is what the final velocity is at this point here when it impacts the car. Okay, we're trying to determine, based on two different coefficients of friction, what's the velocity there. So, if we think about our equations of motion, I see I got an initial velocity given to me, a final velocity, and I'm also given this distance d. So, by equations of motion, I think immediately of using v final squared equals v initial squared plus 2 times my acceleration multiplied by x minus x initial. And as I observe in this drawing and in the problem statement, I can see that my x minus x initial, the distance traveled, is just the d value given to us. So if I have d and I have v initial, I want v final, then the acceleration here is the only other thing I need to solve. So if I can find that acceleration, then I should be able to solve. So let's see if we can't figure out what that acceleration is. In order to find that, I immediately think of my sum of my forces. So if I draw my car here and try to do a free body diagram for it, here's my car. Apparently, since it's a convertible, it's nice and low. There's my windshield. Such a beautiful picture. So what forces do we have acting on it? Well, going straight down we have its weight. And going up the hill we have the friction force, that braking friction force. We know it's kinetic since we're sliding. And in addition, we have the normal force perpendicular to the surface off over here. Okay, so we need to define our axes. I'm going to go ahead and define this as my x-axis, and this here is my y-axis. Okay, and I can observe here that the angle that the weight makes relative to the y-axis is the angle theta given to us in the problem statement, as we've seen other times. So if we go to set up some of the forces, we're looking at some of the forces, let's say, in the x direction. Well, the sum of the force in the x direction should be equal to mass multiplied by the acceleration. If it's accelerating up the ramp or down the ramp, that will give it to us because our acceleration is entirely in that x direction. And then in the y direction, maybe I'll box this off over here. In the y direction, our sum of our forces will be equal to 0, since he's not magically flying up off the ramp or crashing through it. So what do the sum of our forces look like in each of these cases? Well, in the x direction, we have an x component of the weight. Let's stick with our colors. So we got mg, and the x component is this component here, which is the opposite side, so mg sine theta. And then we also have, as you can see here, the force of kinetic friction up the hill, so minus Fk equals ma. Alright? Cool. So if we want to find the acceleration, we need to determine what our force of kinetic friction is. And we know from definition, we can make a substitution that the F sub k value is equal to mu k, which is given to us in the problem statement, multiplied by the normal force. So if we can find the normal force, we should be able to move forward. So let's go over to the sum of the forces in the y direction. What forces do we have in the y? Well, I see in the positive y direction we have the normal force. Then in the negative y direction we have excuse me, in the negative y direction we have the component of the weight, so minus mg cosine theta, and as we already established, the sum of our forces in the y are equal to 0. So we can easily see our normal force is just going to be equal to the mg cosine theta. Okay, so let's go ahead and make some substitutions in here. So we now have mg sine theta minus, we'll just stick with red, mu k multiplied by the normal force, which is mg cosine theta, and that's all equal to ma. So you can see here, look at this, boom, m m, m in each of the terms, and so those will cancel out. And so now you have a situation where you can solve for the acceleration a, because we know theta, we know g, we know mu, we know theta, we know g. You can solve for the acceleration and use it, hopefully, up here to determine our velocity. So I hope that helps, and I hope you guys can rock and roll with this and the rest of the homework. Let me know if you have more questions.